This video is about emission spectra. An emission spectrum is formed when a gas emits electromagnetic radiation. So let's begin our explanation with a gas cloud. As the first step, we supply energy to this gas cloud. This is usually done by passing an electric current through the gas. The details of how this exactly happens are not important for now. This energy is transferred to the electrons in the atom, and we say that electrons in the gas atoms are excited. This simply means that as the result of the energy transfer, electrons transition from lower to higher energy levels, and the temperature of the gas increases. After some time, we stop supplying energy to the gas. As a result, the gas begins to cool down and it loses energy. During this process, electrons in the gas atoms transition from higher to lower energy levels and emit energy in the form of electromagnetic radiation, in other words, photons. When we learned about the electromagnetic spectrum in topic 4, we saw that only electromagnetic radiation that has a wavelength between 400 and 700 nanometers is visible to the human eye. Let's assume that the radiation in this example falls into the visible range of the spectrum. Therefore, the final step in the process is that the electromagnetic radiation, so the visible light emitted by the gas, is allowed to pass through a glass prism. The light that emerges from the prism is projected on a screen, and as a result, an emission spectrum is formed. Let's see how this process looks like on an energy level diagram. For now, we are not concerned about the specific energy level values, so I did not include these on the diagram. So we said that when energy is supplied to the gas, electrons are excited and transition from lower to higher energy levels. There are 6 different transitions that can happen from a lower to a higher energy level on this diagram. Let's represent these 6 possible transitions. So again, during this process, each electron absorbs a photon and as a result gains energy. Let's see what happens as the gas is cooling down. During this part of the process, electrons lose energy by emitting a photon. As a result, transitions happen in the opposite direction, and electrons move from higher to lower energy levels. Once more, there are 6 possible transitions. As a result of these transitions, an emission spectrum is formed, which looks like this. On this spectrum, frequency and energy increase from left to right, and the wavelength increases from right to left. What you see here is part of the visible range of the electromagnetic spectrum. So why do we only get lines with certain colors instead of getting the entire continuous spectrum? Here's the explanation. During each transition that you see on the energy level diagram, a photon is emitted. A longer arrow on the diagram means more energy lost by the electron during the transition. Of course, this also means that a longer arrow represents more energy carried by the emitted photon. In the previous video we learned that energy levels are quantized. Therefore, the photons that are emitted during the transitions can have only 6 different energy values. So we can say that only 6 different types of photons arrive to the screen where the emission spectrum is formed. As a result, we get 6 distinct lines on the spectrum instead of seeing the entire continuous spectrum. The more energy a photon carries, the closer the emission line formed by the photon will be to the violet end of the spectrum. So as you can see, the longest arrow corresponds to the violet line, the second longest arrow to the blue line, and so on. This completes our discussion of emission spectra. In the next video, we'll learn about absorption spectra.